The core objective of predictive analytics has always been consistent: use historical data to optimize your enterprise decisions. 5 years ago, an analytics team could succeed by building a few strong models and refreshing them on a quarterly schedule. Today, executive teams require AI analytics to update at business speed. That means processing much larger datasets and deploying resulting scores continuously across web applications, across mobile platforms, and edge environments. But this is where organizations hit a wall. Highly accurate legacy models often fail to deliver a return on investment when they are moved into these fast-paced production environments. The friction here isn't in the math. The barrier to scaling enterprise AI is the architecture of the end-to-end operational workflow. We can see this clearly by comparing traditional, siloed predictive environments, like SAS 9, against modern, cloud-native AI pipelines, like SAS Viya. The goal of modernization is to find a way to achieve this scale while protecting the compounded value of legacy models and trusted data pipelines. Traditional platforms earned their reputation for a reason. They provided highly structured, audit-ready visual process flows for critical tasks, ranging from credit risk assessment to churn prediction. This diagram illustrates the architectural divergence. On the left, we have the sequential legacy pipeline with its rigid, disconnected nodes. The first constraint is compute capacity. Because the system relies on fixed on-premise infrastructure, processing power is strictly capped. That compute bottleneck is compounded by process limitations. The workflow relies on slow, manual tuning, and execution is strictly siloed by specific job roles. Finally, we hit the deployment friction. Custom, IT-heavy deployment paths create a disconnect between when a model is created and when it is actually operationalized. With these structural barriers in place, model performance often degrades against real-world conditions before the scoring process can even be put into production. Now look at the modern enterprise AI pattern to see how these bottlenecks are resolved. The foundational upgrade here is the shift from fixed infrastructure to elastic cloud compute. By pooling resources on demand, heavy tasks like model training or batch scoring on millions of records execute as parallel, scheduled jobs rather than stalling in a queue. This scalability allows us to introduce automated machine learning, or AutoML, at the very beginning of the modeling pipeline. AutoML does not replace data scientists. It acts as a rapid baseline generator, instantly exploring algorithms and running hyperparameter tuning. Consider a retailer executing demand forecasting across hundreds of distinct product categories. Instead of manually building hundreds of regressions, AutoML instantly generates foundational models for all the low-impact standard retail categories simultaneously. This automated baselining frees up human data scientists to spend their cycles manually refining only the highest impact, highly complex category models. Substituting elastic compute and automated baselining for manual setup tasks compresses the time to impact from months to hours. Modern enterprise data teams operate in a hybrid ecosystem. They blend legacy SAS knowledge with open-source innovation. To support this, the modern architecture utilizes a hybrid API layer. It natively integrates SAS logic with open-source languages like Python and R. This extensibility means teams can utilize best-of-breed libraries without triggering costly code rewrites or sacrificing enterprise-grade governance. But a model is useless if it stays in the lab. A data scientist's local notebook is not a valid production environment. The modern MLOps approach replaces those custom, isolated IT handoffs with standardized CI/CD-style promotion pathways. These repeatable promotion pathways ensure that models can be pushed to diverse operational channels consistently and safely. Standardizing this exact deployment pathway is the mechanism that transforms predictive analytics from a descriptive research exercise into an operational business engine. Scaling AI does not require burning down your legacy infrastructure. The industry myth of rip and replace actively destroys validated models and institutional knowledge. Smart modernization requires a triage methodology, an inventory framework to categorize existing legacy models. The first path is rehost. Stable, high-performing models migrate to the new architecture with minimal changes, preserving their legacy stability. We refactor models that require partial rebuilds due to new data sources, and retire the legacy logic that is no longer business critical. This phased modernization strategy protects your legacy business momentum while systematically stripping away the limiting constraints of the old execution environment. This modernized architecture does introduce a new operational risk. As AutoML and elastic compute exponentially increase model throughput, traditional manual governance becomes a liability. The solution is programmatic governance, baked directly into the workflow architecture. The system executes lineage tracking, automatically documenting data origins and identifying who approved production models. It also handles drift monitoring. Live telemetry flows continuously from production to the system to detect accuracy degradation. This live telemetry can automatically trigger reevaluations or kick off fresh retraining pipelines entirely without manual intervention. These automated controls are non-negotiable for regulated sectors, like banking or healthcare, that must constantly prove compliance to auditors. A mature enterprise architecture uses these automated controls to maintain the safety and compliance required for high-velocity deployment. The required architectural transformation is clear. Organizations must move away from manual, siloed iteration and embrace elastic, automated CI/CD style pipelines. The fastest, safest path to AI maturity is building directly upon your already trusted data pipelines and proven predictive models. For IT leaders planning this transition, begin with a single, highly focused pilot project. Choose one with a measurable ROI and a clear deployment path, and embed the programmatic governance framework into your system delivery process from day one, well before you begin scaling up model volume. Achieving enterprise AI scale does not require an organization to start over. It requires thoughtfully upgrading the surrounding execution system in order to fully unleash the power of what already works.